All right, in this module, we're going to go over the conditions that favor glass formation as opposed to forming crystalline materials. So we go over criteria for glass formation, and it's based on two main factors, those being entropy of formation, so the entropy value associated with the formation of crystals, and the viscosity of the fluid. So, but there is also other criteria. So let's look at the kind of three conditions here that we've set that we need to form glasses. So we want low nucleation rates, right? So that goes back to our discussion of nucleation and growth. By lowering the nucleation rate, it means that we can minimize crystallization, and so that can be done with a small entropy or a large interfacial energy. Also, for glass formation, we need a high viscosity around the melting point. So the melting point of that material, the viscosity's got to be high around those at that particular temperature. So this results in low growth rate. So the first is about nucleation rate. This is more about growth rate because the diffusivity is going to be controlled by viscosity. And then the last one is more of a general consideration. We talked about homogeneous nucleation, so nucleation on some type of surface. And so in general, we want to have the absence of these things. So seed crystals, any sort of impurity that would act as a surface. So we don't really have a way of kind of putting that into an expression. We just generally want to avoid that. So this gives us our expression for a criterion for glass formation. So we want to have this term, the entropy of formation, be low, and then we look at the viscosity, and we want the viscosity be high, but we're looking at the reciprocal, so that means this term is also low. So basically we're looking for the lowest possible number, and those are the best glass formers. And then on the other end, the higher the number is, the worse it is at forming a glass. So let's take a look at some various compounds and their sort of glass forming ability. So we look at boron oxide, silicon dioxide, which we know of, and then some other materials like silicon or sodium silicate. Both of these are various types of that. Germanium, phosphorus, other compounds, and then sodium chloride down here as a reference. So there's listed their melting point, and then the viscosity is going to be that at the melting point, and then we have the entropy of formation, and then the criterion is here. And you see that towards the up here at the top, you see these have really low numbers, right? And that means that it's an excellent glass former. And as the higher it gets, you see that the worse it is. So this is higher, it's only a good former, and then here they're listing it as poor. And then all the way to sodium chloride, which is a very high number, which means it doesn't readily form a glass. And so the big thing, the big takeaway out of this is that if you look at the two factors, entropy here and then viscosity here, you see the entropies, they range from about 5 up to about 40, right? So 5 to 40 joules per mole K. However, the viscosity, which is Pascal's second, ranges all over the place from 2 to the minus 3 all the way up to 10 to the 5, right? So orders and orders of magnitude difference, right? So what we see is that of these two factors, the entropies are pretty close if we compare that to the viscosity. So the viscosity really dominates the expression. So this viscosity at or around melting really dominates whether we form glasses. And we see that the entropy of formation really doesn't have a large effect in these cases. And so that's the dominating factor. And that's kind of what we're showing here, is that it really must have a high viscosity. And so we see the problem with sodium chloride. When it's melted, it has a very low viscosity, and therefore the diffusivity is going to be very high, and it's going to form a crystalline material. All right, so what I wanted you to do in this case is, obviously it's in the previous slide, but take a look at the numbers that we have for germanium in this calcium silicate, and calculate that criterion we just talked about. And I'm just giving you those values. And again, which one is going to be form a glass? If you had to pick which one is more likely to form a glass, and then obviously give your rationale. So take a second, make those quick calculations, and then we'll come back and discuss. All right, so again, this was listed in the table. It's more or less dividing one by the other. And so if we just sort of give you the rest of the table here, you'll see that germanium, which is right over here, is 2 times 10 to the minus 4 is the criterion. And then the calcium silicate over here is 30, right? So this is a much lower number, and so it's going to be the better of the two glass formers, and we see that this is actually quite difficult to form a glass.